Great. Kia ora, everyone. So today I'd like to just give you an overview of the TAIAO project. So this project funded by MB. This is a 7-year project. This is with University of Waikato, Auckland, Canterbury, Victoria University Wellington, Beca and MetService. And I'd like to explain a little bit what we are doing, and then at the end I'd like to do an announcement about WECA. You know, that's a software that at University of Waikato has been developed for many years. So I'm going to do an announcement, and I'll try also to do a demo. So maybe that's going to be fun because usually demos are quite hard. Just to say that the best thing of this project, TAIAO, is the team. So we are very, very proud of having all of these teams. So I'm not going to tell them, but it's really, really the best thing. And this is, I think, the main reason why we are having so much fun, and we are really, really enjoying being part of this project. So how this project benefits New Zealand? So, first is we are focused on excellence, so we try to publish at the best conferences on AI, just doing fundamental research on AI. But then also at the same time, we are quite applied, so we work on environment, and one of our things is to grow the capability, right? So just to create the next generation of AI researchers and environmental researchers that they work with all of these, and that's the main thing. And also we are very collaborative, so we really like to work with everyone. And finally, we like to give effect to the vision Mataranga. So maybe our main goal is to create this community, right? So you are very welcome to join us, to join this community. So we have this website, TAIAO.ai, where we have, basically what we try to combine the data sets, notebooks, and discussions, and we provide also all the open source software that we work. So the first thing is data sets. So we have this nice catalog of data sets that you can take a look. We don't store the data. We have only the links where you can get the data, but it's very nice to have all these data sets available there. As many people use Python, right, to use notebooks. So as you know, the big advantage of notebooks is that we have the source code, the documentation and the results in one document. So this is very convenient. So we have the data sets, but we also have the notebooks so that people can get and can discuss about that. So one of the main things of this project is the time evolving part. So we are really interested on working with time series, but mainly with data streams. And so at the University of Waikato, we had MOA. It was a software in Java. It was really the state of the art. But now with Python, we really need to have a Python tool. This is why we created this River tool. This is a tool created with researchers in France. In fact, it was the merge of two projects. One was called Scikit Multiflow. That was more academic, and another that was more industrial was Scream. So we got this River project. The main issue maybe is that this project is in Python, so it's not very fast. So this is why Heitor Gomez here at Victoria University of Wellington, he decided to create it was a good idea to create a new software that was in Python, but much faster, just using MOA as a backend. So this is really, really good. If we look at the results, so for example, this is running a adaptive random forest. We can compare how much time it takes to build a model. Using River, it takes 2 hours, and using MOA or CopyMOA, it uses only 4 minutes. So this is why right now we are really focused on CopyMOA, because it's a tool that is growing a lot. Has a huge community, and we are very, very proud of how things are going, and we are really keen to work on this project. We have many, many different projects. So maybe one of the most popular ones is this species classifier. So this is a tool. This is a species classifier that runs on the mobile. So you can go to a forest, you don't have any connection, you don't need the cloud, and your model is going to be running there, and you'll be able to, just take a picture, and it's going to tell you what's the species. It's going to give you also the other 5 predictions, and it's also going to give you an explanation of what are the pixels that were used to make this prediction, and also then it's going to give you information on the Wikipedia and also the Maori one. So we have been working on different projects, so I'm going to mention only some of them, not many. So I need to filter due to the lack of time. So maybe we have this flood and hazard platform. So the idea here is to use this data mesh architecture. So instead of having everything on a data lake where we put all the data in one place, what we are doing is that we are distributing the data sources. So the idea is we are going to have APIs, and we are going to be connecting to the different, what we call data products, where we get the data that we need to build our models. So this is data mesh architecture we have been using in several projects. One of them is this flood prediction that was with Waikato Regional Council and MetService. So the interesting thing was, we were able to do that on real time, connect weather data from MetService and connect data from Waikato Regional Council, and with that we are able to get this. We can see this dashboard where we can get this information in real time. So this is a project that Nick Lin and Phil Mugo were leading. Related to that, we have a PhD student, Leah, that she's doing the PhD with University of Waikato, but also with Institut Polytechnique de Paris. So this is a dual PhD. And related to this, so she was very, very keen to participate in this global industry challenge in the World Bank track, and try to use these quantum tools that she's using for her PhD. So in this case, that was a project with Savari Punambalam, Jacinta May, and Nicolas de Mateis. So they participated at this Global Industry Challenge, and they won. So that was really good. So it's really something nice because they presented this at the World Quantum Conference in Washington. So that was really, really something that we are very proud. Maybe another project could be related to a collaboration we signed with the Forest Flow project. This is a project that Guillermo Casales with Seragis, Salekin, Dim Misan, and Nick Lim. So the idea was the idea is they have all of this data from sensors that they are using this data mesh architecture. But in this case, what they wanted to do something more is that they wanted to use explainable AI. They wanted to really, really try to get explanations of what was happening, right? So, as you know, it's very important not just having the predictions, but also trying to understand how that works. So I think that was also a very nice project from this. Maybe another one that was from Thomas Valley, Yun Sinko, Kartik Mukavili, and Barbara, that is here. So the idea in this case is how to improve this global weather forecasting with using hierarchical graph neural networks. So the idea is that, as you know, global weather maybe is we can see that as a multi-pole space-temporal scales data. So we need to be able to see how we can do that, and then they decided to use this hierarchy machine learning, using hierarchical graph neural networks, proposing new ways to do that, and they got very, very good results. Maybe another nice project was this anomaly detection for ship path. So this is from Jacques Julien, Yun Sinko, and myself. So the idea here is that we have these ships, we know the path, and we would like to know what's not normal, right? These anomalies that could be something could be related to illegal fishing, route deviation, hazardous operation. So the problem is that we use standard anomaly detection models. This is not working. This is why in this case we were using this continual learning methodology to be able to adapt and try to detect these anomalies when they happen on real time. Great. Another project, it's this from Guillermo. That was a collaboration with University of Cardiff, Guillermo Casales, John Petri, Aitor Gomez, Omer Rana, and myself. The idea here is to use edge machine learning. So the idea is that we have these solar panels, and the idea is to be able to do that on the edge to forecast solar power and energy prices on real time, and using that at the edge. This is something that, there is also this idea that sometimes not everything needs to be done on the cloud, and then Edge AI helps on being able to do this machine learning on the devices. So this is something that is quite, it's quite relevant, and I think this is something that is going to be more and more in the future. And going back to the different projects. So in just starting to talk about Weka, so we had this collaboration with NVIDIA. So the idea was to have a version of Weka that was accelerated. So it means that it runs on GPUs. And that was a collaboration with Guillermo and Justin Liu. So the idea was to really have a version of Weka that really speeds up and uses the GPUs. In this case, we were using software from NVIDIA to be able to do that, so that's why this collaboration with them. And finally, just starting to see, so I have the pleasure today of announce that we have a new version of Weka that we call Weka.ai, and this is a version of Weka that is going to be running on the cloud. And for that, this is a software that has, development of this software has been led by Nilesh Verma. And I'm going to try to do a demo. So, demos never work, so don't be too. Okay, so just to okay, of course it's not working. Let me see. Okay, good. So if you remember, the classic Weka software was working like this. We're opening a file. Getting, for example, the iris data set, right? So we could be able to see the different attributes and the class. And then, we're able to just transform, preprocess the data, and then in classify, we're able to run the machine learning task. So, for example, here we're able to choose just a decision tree, G48, we run, and we get the results, right? So we get the corrected classifier instances, we get the confusion matrix, all of this. So, now the idea is if we want to have a modern version of Weka. So the way to do that is on the browser, right? So this is why we are presenting this new version of Weka.ai, still in alpha stage. So still we are really very excited about it, but still we need your feedback on how to improve it. So we have like three different tools, Weka Web, the Weka Terminal, and the Weka Copilot. So let me start, just first signing in. So I'm going to sign to the software. And I'll start first with the Weka Web. So this is a version of Weka that runs on the browser, right? So I'm going to start a new session. So here you can upload your data set, or we can use a quick start. In this case, we choose the iris. And here we can see all the different features. You see that there is also this telling us that there are some duplicate data detected and outliers detected. So this is the data loader. We have the preprocessor. So here, for example, we can try to data clean and remove the duplicates. So we add to the pipeline, we apply. So and finally the machine learning task. In this case, we can do classification. So what we can do, we choose a decision tree, we run the machine learning task, and here we see the results, right? The accuracy, the confusion matrix, and we get the same results as in Weka. Here also we have these ROC curves, this precision and recall, the learning curve, and classifier. Okay, so that's the main Weka, but running on the browser. And we have also other things, extra things that we can do, like attribute selector, data visualization, or experiment. This is something I really like. So we can choose, for example, to select what's the data set, and we run the experiments, and then we'll get the different classifiers with the different accuracies. So yeah, it's very simple to run and very... So yeah, that's a Weka Web. That's the version that runs on the browser. What we have is the Weka terminal. This is just only to run the Python code. So what we are doing here is that we are using Weka Python wrapper. So the code is in Python, and then everything is executed in Python, but in the backend is the Java Weka of the classic Java Weka. So yeah, this is the terminal, and we'll see that we are going to use that in the Weka Copilot. So again, so what's the new way of dealing right now with user interfaces is using a large language model, right? So here we are going to do a new chat. We can do, I want to write a Weka code for machine learning analysis on my data set. Please update your CSV or R file. Okay, I'm going to update. Here I can use these data sets. For example, I can use the iris one. Okay, done. And now I can say, okay, build a decision tree. Okay, now I'm saying, generate a Weka code to build a G48 decision tree classifier on your iris of dataset using cross-validation. And then, so here's the code. We only need to run, and we'll get the code. And you'll see it's the same one that it's, we can say that is really, using Weka. So it's a nice way to interface. Maybe it's quite easy and nice to use. So, I think that's this is the Weka Copilot. And as I said, we have these three things that they work together. Again, this is really, really alpha. So we'd love to have your feedback and see how it works. The way that this is going to work is that as many people, they already have their own large language models. The system allows you to use your own, maybe OpenAI or your own keys that you are using on the API, so you have access to better models. Great. So that's this Weka. Mm-hmm. And just to tell you about, we are organizing this event this week in Paris. That's on Friday. That's called Bridging Horizons. So we have a delegation of AI researchers that is led by Stephen McDonald from Victoria University of Wellington. And we are going to be organizing this event there, where we are going to be joining the researchers in France, in Paris. So this is done at the École Polytechnique in Paris. So this is one of the most prestigious school in Paris. And we are going to have this event when the two communities are going to be sharing. So one of the main goals is really to work and to see how we can collaborate in Horizon projects, in EU Horizon projects. So this is something I think is very important for us here in New Zealand, so it's really good to be able to collaborate on that. At the same time, we would like to launch this TAIAO AI Research Network. So this is an international research network where we try to put everyone that is interested on working on AI for environmental science, data science for environmental science. We can work together. So yeah, this is this event that is going to happen in Paris, and also we are going to try to also launch the WECA AI there. And for the ones that you know, Scikit-Learn. So Scikit-Learn is a project that was created there at this university. So it's really good to be in the same building, just presenting this new version of WECA. And yeah, this is something that we are quite excited, and this is going to be this next Friday. Okay, and just to finish, yeah, I wanted to mention that this is we are already arriving to we are finishing the 6th year of this project, the TAIAO project. I think that's a project that we try to do our best to first create research excellence, then to grow the capabilities and to network people. And yeah, we are really happy, we're really proud of everything that we have achieved. And again, the main goal is to create this research community. And we'll be very, very happy if you are keen to collaborate with us. So with this, I'll finish my talk. Thank you very much.